Alright, so in this lesson we're going to talk about systems of linear inequalities. Now, that sounds kind of intimidating, but understand that this is math that we've more or less done before. What you're going to end up seeing is the whole graphing a line and shading one side of it. The difference is instead of graphing one line, we're going to be graphing two or more, hence the name systems. So the actual process here should be review, but the concept of it I want to pay some attention to, so I think we'll frame this in the context of a word problem. So basically you have two after-school jobs. One job, raking leaves, pays you $4 per hour, and the other job, tutoring, pays $8 per hour. So we're going to have a couple of restrictions on this. To pay for your expenses, you got to earn $56 per week at least. Notice the word at least there. So it's not saying I have to earn exactly 56, but more is okay, but it has to be at a minimum 56. But then also, because we have school and homework and other things, we can work at most 10 hours. So a couple of restrictions. Again, not exactly 10 hours, it's at most 10 hours. So the goal is to find out what combination of hours for the job should we work. So should I work 5 hours at one and 5 hours at the other, 3 hours at one and 2 hours at the other? And the reality is there's probably a lot of answers to that. So one of the best ways to solve a problem like this is to actually graph it so we can see all of the many right answers we have. So let's make a couple variables. Let's say that x is the number of hours raking, and y could be the number of hours tutoring. And again, I want to figure out what hours so that I make at least $56, but at most work 10 hours. So let's write a couple of inequalities for this, and we'll start with the hours because that one's a little more straightforward. So the number of hours I rake plus the number of hours I tutor should be at most 10 hours. So less than 10 is okay, but 10 is the absolute maximum, so less than or equal to 10. And then the other one is going to deal with money, and we've seen that before. So I make $4 per hour of raking, plus, boy, $4, that's not a lot for raking, oh well, plus $8 per hour tutoring, and I need to make 56, but more is okay. So greater than or equal to $56. So there's my system. Now, again, probably the best way to solve this is going to be to make a picture of it, to graph it. And so we've done this before. The first thing you want to do is you want to solve. Okay, that is not how you spell solve. You want to solve the equations for y. So let's start with the first one. So I've got x plus y is less than or equal to 10 minus x, like such. So y is less than or equal to minus x plus 10. So there is one equation ready to be graphed. Let's do the other one. So 4x plus 8y is bigger than or equal to 56. So we'll minus 4x from both sides in the usual way to get y by itself. So 8y is greater than or equal to negative 4x plus 56. Divide everybody in the pool by 8, like such. And y should be, now be careful here, we're dividing by a positive 8 so we don't have to worry about it, but if we were dividing by a negative 8 we would most definitely have to change the inequality. But we won't have to worry about that here. Negative 1/2 x, and 56 divided by 8 is 7. So we solve these guys for y. So now we have two ready to graph equations. So let me graph the first one. I'll do this one in green right here. So I'll put a little green star by it. We know the y-intercept is 10, which is actually a little bit off my graph here. So I'll plot that way up here, like such, at 10. And I'm going to go down 1 over 1. So down 1 over 1. And I'm going to actually do a couple of points here just to try to get some sort of accuracy on this graph. And forgive me, I can't use a ruler here on the iPad, so this line is going to be a little bit sketchy. Yeah, really sketchy. But it works. And notice here that this line is solid because we have a less than or equal to sign. Now, Now I have to figure out about shading, and because it's a less than, I'm going to shade below the line. So to do my shading, I'm just going to draw some lines here so I don't get too messy on my graph, but hopefully you can kind of see that there, shading. And I've got my line, I've got my shading, and so anything that's shaded here is going to satisfy the number of hours I work at the job. So pick any ordered pair in this range and we'll be good. Now let me graph the other line. This one's a little bit more involved because I have to worry about a slope of -1/2, but the y-intercept is 7. So I'll go blue for this guy, and I'll put the slope right there. And I'm going to go down 1 over 2. And again, I'm going to give myself a couple of points here and try not to completely slaughter this line. Ooh, that one's pretty good. There's that guy right there. Now, let's shade this guy. This one says to, and by the way, that's blue. This one says to be greater than, so let me shade the greater than, so that's above the line. Okay, so I'm up here, like that. There's the above the line. So now I've got the two lines there, and what I'm actually interested in is the overlap, the overlapping shading. And so if I look at where the blue and green are overlapping, it's right in this area here. Okay, that's where the two shadings overlap. So these are my answers. These are the combinations that satisfy both the money I make and satisfy the hours I work. And you can kind of see that right here. If we look at, let's say I work 3 hours on one job, and I work, let's say, 7 hours on the other. So we're basically saying over 3 up 7, so there's the 0.37 right there. That is going to satisfy the amount. I'm going to work exactly 10 hours, so I'm not exceeding it. And then also, if you do the money amount, you're going to make at least $56. Where anything outside of that shading, you're either going to have too many hours or too little money. And so, but this gives us all the ways to visualize all of the solutions. In fact, let's just take a second and try a couple of solutions, just so we can kind of make the connection with how that graph is working. So let me just move this down a little bit here. And so we said 3, 7. So, for example, let's say I work 3 hours at one job, 7 at the other. So 3 plus 7 is in fact less than or equal to 10, right? Because 10 is less than or equal to 10. It works there. Let's check the money. The money says 4 times 3 hours raking plus 8 times 7 hours working. So I'm going to end up working tutoring. I'm going to end up with 12 plus 56. Now I'm going to end up with a surplus here, $68. So that works as well. Let's just see at least one example that doesn't work, just so you can see why. Let me pick a different point here, and let me grab a different color for that as well. Let's do yellow here. Let's say I work 2 hours on one job and I work 4 hours on the other. So there's another data point right there. Now notice it's in the green shading, but it's not in the blue. So it should satisfy one but not the other. So that was the point 2, 4. And let's see how that works. So back down here for 2, 4, let's check the hours. 2 hours plus 4 hours is certainly less than 10, so it works for that one. But let's check the money as well. 4 times 2 hours plus 8 times 4 hours gives me $8 plus $32. $40 is not enough. So it satisfies one, but not the other. And that's why it's not in the overlap of the shading. So graph, shade, find the overlap. See you tomorrow.